Hello, this is a very short video showing how it would look like if you are using a script-based solution to do the heart rate variability analysis in Acknowledge. Because usually, we have here in the analysis menu, we have the heart rate variability algorithm are already predefined. So you just choose your signals and run the analysis. I will just show this. This is the manual way of doing it, and you get the results, and that's it. This is in a way easy, but there are some things here. Sometimes you have to do this. You have to first, before you use this built-in routine, you have to make sure the ECG signal is clean. That it has only the normal beats in it. If we look at this particular signal, I do find rate here, you see that there are some ectopic beats here, and this will destroy the heart rate variability index. So this, although you can do it, it doesn't make sense. So what you would have to do is to actually zoom in and manually correct this signal before you do the analysis routine. And the only problem with this is that it takes quite some time, and there's manual work, so it gets a little bit ambiguous. So in these cases, it would be nice to automate this, so you don't have to do it manually, especially if you have maybe cases where you have a lot of artifacts, a lot of ectopic beats or motion artifacts or whatever, or you have a lot of data. You have a lot of files, and that's another thing. Here I have an example with a folder with, okay, this is just 4 files, but this could be 100 files. And then you can also, in scripting, there is it. You can use a script that automatically loops through a given folder and does the same analysis on each of the files automatically, and then, for example, puts it out to an Excel sheet. And this is what I will show here in this example. I will close this. I have now made a script. So if you have the scripting option to Acknowledge, you get this menu and you can open, which is something called the script editor. And then now I will show one script which I have written here as just a simple example script. Of course, all of the actual analysis routines that is built into Acknowledge, they are also made by BIOPAC, but such similar scripts. But you can also do your own custom scripts. And the idea is that pretty much everything you can do manually in Acknowledge via menu options, find cycle, filtering, everything. All this you can also code into a script. And just to show you how the script looks like, here I have one script which is called batch spectral HRV with ectopic reconstructions. That's just the name. So all these things after the semicolon, that's comments. So I can make this a little bit larger. So I will not go through all the scripting here. I will just show how it looks like. You'd see that it's scripting code. It's easy to read. It's, if you have done anything like BASIC or something, it's quite easy to learn this once you have gotten used to it. So the first parameter here is the path name, the Windows path name to the folder where I have Acknowledge files that I want this script to process. So the script here is first it basically looks into that folder, gets a list of all the files, and here I am preparing an Excel sheet which will, at the end of this script, is where I will get all the outputs from all the data files. So I'm preparing here the rows and the columns in the Excel sheet. And then this is the end of the script. So what this does is it basically loops through all the files in the folder, and then once for each file it opens the file and opens the graph in the file, and thus outputs the name of the file to a certain column in the Excel sheet, which I defined just like I wanted. This is my report Excel sheet. And then for each file it calls another script. It's called spectral HRV. This is the line. For each file it calls this analysis. And now this analysis then we can find here. It's also stored in this file. This is also a custom file. This is not anything standard that comes with knowledge, but this is something you can write on your own, and this is a sample that I have made. So as usual, there's just comments, and here starts actual scripting. I have defined here all the variable names I'm using. There should be really more comments in this code, but this is just an example. And then I start doing several things. First section of the file here, I will not go through each line. I check the sampling rate, so I resample the data to something that is appropriate for the actual analysis I want to do. For example, I resample the ECG, and then I do the find rate. So from the ECG signal I create the RR signal, and the RR signal is then what I later use to detect any, because any ectopic beats or motion artifacts will show up as large deviations in the RR file. And then of course there's different methods to do this correction, so there's not really a standard for this. So in this code I've toyed with, I think originally I had several methods in here, but now there's only one, which is where I first use a method. I smoothen the RR interval. This analysis on the whole file. All of the files are 5-minute recordings. You can also put in events in this analysis, but in this case, all the files in my directory are 5-minute files. I smoothen the RR file to get a smoothed, so that median filtering takes away all the spikes, and then I compare the original RR file with the smoothened one, and then you get a gating, so you can gate out all the sections of the original signal that is suspicious, so to speak. And the thresholds for doing this detection is something you choose in the code, and I've made the choices here. And then I do have some tricks. To make this easy, I normalize the RR file, so I get the standardized detection threshold in terms of a percentage instead of something related to an absolute heart rates. Okay, so you see, this is just how the code looks like. Set measurement. This set measurement corresponds to the measurement boxes you do here. So the script actually does this for you. So and then transform here, it means calling the transformations like you do manually from the menu. So when you actually run this script, the acknowledge will do it just like you do it manually, but it will just do it really fast, and you will see all these measurements boxes just flickering, and the analysis will go real fast. So it loops all the files. It's not possible to go through the details, but you see there's some lines of code, and after in the end here I take out measurements, which I then put into the Excel file. So let's visit here. Let's see how many lines this. Okay, 400 lines of code. It's not too bad. So let's now see what happens when I run this. So the first thing you do is you go here, because you make this once, and then all you need to do is change here the path to your latest directory where you have all the files, and then I press run. Now it starts working, And if you have a lot of data, a lot of files, this can actually take some time, so you can go get some coffee or something and just back and watch. So as you see, the scripting actually does mark sections, and just like you do it manually, but it does it all automatically real fast. So this is why you usually, when you write a script, you do it first manually, so that you understand exactly what steps you need in the scripts. And the next step is to look into the documentation and find how to actually find the code for those particular operations that you usually do manually with the mouse and the menus. So now this is not too much data. Okay, here it's already done. So here is the output. So my script here has generated automatically an Excel file, which looks like this. Here I have the first column. Here is just the name of the various measures that I have chosen to define, that I want in my file. The actual formulas doesn't carry over properly from the scripting, so you can just enter the text of the formula and do like, okay, sorry. Let's complete this. Okay. So here I have the measures. This is the very low frequency divided by the total power in the heart rate variability. This is the integral of the spectrum. This is the various heart rate variability measures. The HF spectrum, this corresponds to the parasympathetic index, and this is the low frequency spectrum. And then for each recording, then I have one column here. So now I have 4 data files, and let's just look at these 2 indexes just to take an example. And well, this is what you get. Very easy. And of course, once you have your data into Excel like this, I mean, you can do everything. You can easily also copy it to anywhere and make statistics. And this would work just as fine if there was 50 files, but it would have taken longer, more than a minute. This took a few minutes only. And this Excel you can format these columns any way you like from the scripting. So that's just a simple idea of what you can do with the scripting and how you can really save time. The only thing then is that you need the scripting license option to acknowledge, which you can buy if you don't have it from the beginning. And then you need to spend a little bit of time to get familiar with this, which is called the BIOPAC scripting language. But as you see, it's not too abstract. It's a basic like language. So that's it.